All right. Hi, Aaron. So it's a pleasure for me to welcome a very precious and beloved family member and friend of mine. Aaron Sonabend is a research scientist on climate and energy team at Google Research. He was previously at at the same company at Google Search as a data scientist. He received his PhD in biostatistics from Harvard, uh, and he focused on reinforcement learning for dynamic treatment regimes and natural language models for automatic diagnosis. He also studied here in Mexico City. He has a bachelor degree in applied mathematics and in economics from the National Autonomous Technological Institute of Mexico. And we're very pleased to have you here, Aaron. We're now live from our live stream, and the presentation that Aaron is going to give us is focused on building technology that helps people to do more for the planet. So Aaron, thank you very much for being here. And well, it's your time to do the presentation. Thank you very much.
Thank you, Gabriel, for inviting me and the kind words. Yeah, Gabriel asked me to do this in English because I think a lot of people would appreciate this, but feel free to ask questions in Spanish. As Gabriel said, I'm from Mexico City. All right, let me share my screen. Can you see the slides?
Yes.
Perfect. Okay, so let me, sorry, I'm having a little bit of technology problems, obviously. Okay, great. So thank you again for inviting me, and I'll be talking about how we use artificial intelligence and technology in general at Google to combat climate change. All right, just can you confirm you see the next slide?
Yes, Aaron, we can see it.
Perfect, thank you. Okay, so first, like, why do we even care at Google about this? So let me start by telling you that since its conception, the founders have really cared about the environment, and we have an ambitious 10-year strategy for carbon that goes far beyond our operations. So we try to lead at Google and start with how we can operate our business more sustainably, but we're also interested in supporting partners beyond our operations, such as nonprofits, researchers, policymakers, as hopefully some of you here. And we want to provide them with the tech they need to scale up carbon solutions. And also we want to enable the users and everyone else through our products with helpful ways for everyone to be part of the solution. And I'll be talking about a few of our projects and how we do this. All right, so now let me tell you a little bit about my team. We're, as I said, I'm in the Google research team, and the idea is to apply artificial intelligence to a different range of projects where we can either mitigate climate change, so lower emissions, or adapt to climate change. So given that climate change is manifesting itself already, how we can help people adapt. And this ranges from forecasting weather and for agriculture and food security to forecasting locust breeding grounds that are a big problem for food supply in Africa. We're also very invested in detecting and forecasting wildfires. So you probably have heard about the fires in California, for example, where I'm currently located. They're not only very dangerous to and harmful for people and health, but they emit a lot of carbon into the atmosphere. And so we have these satellite detections and artificial intelligence to predict, forecast, and detect wildfires with the idea that we can prevent them from spreading and being too harmful. We're also into extreme weather and heat forecasting, and among a lot of other projects, and I'll be talking about a couple of them. So first, let me tell you a little bit about our mitigation efforts. And I'll start with a project that's close to my heart, which is contrails. So you've probably seen these clouds that are formed. Contrails stand for condensation trails. So when airplanes fly through a certain area of the atmosphere, they form these clouds. And sometimes, if the conditions are right, they will live for around 18 hours. And this is very problematic for a couple of things. So it turns out that they're responsible for around 1% of human caused warming. And so we want to avoid them. And the reason is that in the Earth, we have two types of radiation. One is a solar radiation that comes from the sun. And this is obviously just at daytime. But we also have outgoing radiation, which is the Earth cooling down. And so these contrails reflect both types of radiation. And so during the daytime, such as in the right, we have the incoming solar radiation, which gets reflected by the contrails, and the outgoing solar radiation. And so they kind of in the daytime, you can think of these contrails as kind of canceling the warming and the cooling effect. And so in the daytime, they're not as harmful. But on the other hand, at nighttime, contrails, there's no incoming shortwave solar radiation, right, from space. And so you can think of, we're kind of with the airplanes, with the millions of airplanes that we have daily and nightly, we're kind of putting a blanket or a scarf over the Earth and trapping a lot of the radiation that would have escaped to space, but it bounces back and comes back to Earth. And this is responsible for around 1% of global warming. And so the question is, how can we avoid this creation of contrails? And so this is a cool project that we're working on, because it turns out that this is only a software project. We don't need to change airplane engines. We don't need to change the turbos in the gasoline that the airplane uses. We just need to change the trajectories by a little. And the way that we do this is that we start by detecting where the contrails would be formed in the atmosphere. And for these, we have satellite imagery. And the artificial intelligence that we use is very similar to the techniques that we use in Google. If you have Pixels or iPhones, you probably know that you can search for people or places. And there's a lot of like AI behind these systems that are recognizing who's in the picture, if the picture has a cat or a dog. And so we use this type of technology, or a similar technology that we use in the self-driving car. So if you've been in San Francisco recently, for example, there's hundreds of self-driving cars since a few weeks ago. And what they use is this exact type of artificial neural network, which I'm showing a cartoon of here, which is able to take in an image and then segment it. And so we can see here, it classifies cars differently. We have a train, we have people, stoplights. And so with these similar type of AI, we combine it with infrared satellite images. And then we also have the weather. And there's a satellite called like a geostationary satellite on top of the equator, which has all of America, like North America, Central America, and South America. And it takes a picture or a scan every 10 minutes. And so we have a picture every 10 minutes of the entire atmosphere. And with this AI, we can detect which clouds are contrails and which are not, with a system that we trained here in our team. And so if you kind of squint at this map, you can see these are the Finger Lakes, I believe, and up here is Canada, and down here is the US. And you can see there's like a column where a region of the atmosphere where these contrails are formed. And there's a picture that we asked a pilot to take for us of the exact same region where on the right, where you can see the contrails actually. And so the idea is that if we can detect the regions in the atmosphere where these contrails are formed, we can also predict where they will be formed in the future. And then we ask our pilots to just avoid these regions. And so if we're very happy to say that we recently concluded a trial with American Airlines, which was successful in that we show that we avoided like making contrails successfully. As I said, we made a big splash. You can I'm happy to provide like links if you're interested. But the idea is that before a flight, we sat down with a pilot, and let's say that you're flying from Colorado to New York, and so there's a big contrail region in the middle of your flight path. And so what we would do is we would ask the pilot to drop a couple thousand feet, and in this way we can avoid making contrails. And so again, as I said, this could potentially in a couple or in a few years, let's say, be lowering global warming about 1%, which is not going to change the world, but it's not nothing. And with a few of these projects, we can hopefully make a dent in climate change. I should say that it's not only us working on it. There's a lot of interest. We have a lot of partners. Lufthansa has a seminal paper on this from 2011. Now NASA is also involved, Delta RMI, and the European Union just regulated a few months ago on airplanes not only making CO2 emissions but contrails as well. And so this has been an exciting area to work on. Let me tell you now about a couple other projects. So as I said, we're also trying to enable partners and users to curb their emissions. And we have this big goal of helping more than 500 cities and local governments reduce 1 gigaton of carbon emissions annually by 2030. And we do this is with the Environmental Insights Explorer, which I would encourage you to go and Google it and play around. It's a very fun tool. And it's made to enable cities to understand their emissions and solar potential more clearly. And I'll show you a few examples. So, for example, take traveling by car. We know this is one of the more carbon-intensive activities that people make on a regular basis. And everyone has had, especially if you're in Mexico City, has this experience of sitting at a car for hours on end, just like stopping and starting and stopping and starting again. And it turns out that this is very harmful for the environment. In fact, pollution at intersections is 29 times higher than on open roads. And half of these emissions at intersections come from traffic accelerating and stopping. And so traffic is not only annoying, but is one of the like most harmful phenomena of driving. And so we started Greenlight to help address this and optimize the traffic flow at traffic lights. And so the idea is that we use, again, machine learning and Google Maps driving trends to model traffic patterns and build intelligent recommendations for city engineers to use and modify their traffic plan. And so it can be a very easy solution, such as the one I'm showing here, which is at this intersection, before, let's say you have a lot of traffic, but then after with there are simple patches you can do, such as add an extra 3 seconds of green time going one way in the morning, let's say from 8 till 9 during rush hour. And so the idea is that this is possible, again, as with this, as same as with contrails, with any additional infrastructure. So you don't need to spend money, you don't need to spend material. This is all software based, and it's helping curb emissions. And sorry, yeah. So another thing is, another way that we use our Environmental Insights Explorer with this big goal is that if you go, you can use a Mexico City one, for example, if you're interested, and you can check the regions. And the idea is that we sit down with local governments to check what is the like potential areas of improvement. And so, first of all, we can also analyze, again, with AI and the Google Maps data and satellite data, what is like big culprits of emissions. And so, for example, we can tell you here what's your solar potential if you like how many CO2 equivalent tons a year you can avoid by putting by using solar energy. What are your transportation emissions, your building emissions? And I should say we're really excited because over half of the global population lives in cities, and urban areas account for over 2/3 global energy consumption and more than 70% of global carbon emission. And so we believe that by helping the cities, we can really help curb CO2 emissions. Another example is with these extreme our tree canopy and cool roofs in sites. So you know that extreme heat is another problem made worse by climate change. Each year, extreme heat kills nearly 500,000 people, and heat-related deaths are on the rise, as heat waves are on the rise as well. And so we're helping cities lower their temperatures by increasing their tree coverage. So tree canopy is the one that you see on the left on green. This is one of our like insights explorers. And what we do is we combine artificial intelligence and aerial imagery so that cities can understand their tree coverage and then plan for urban forestry initiatives. So Tree Canopy is currently live in 350 cities globally. And again, if you're interested, please reach out or go into the tool. It's a very user-friendly tool. And another strategy that we're using is for addressing heat islands. And this is building infrastructure that keeps indoors temperatures cooler, like cool roofs. Cool roofs are designed to reflect sunlight and absorb less heat. So as I was talking about the solar radiation before, if we trap it, sometimes I'm sure you've had the experience of being in the summer in a city where it's extremely hot, and sure, there's sun coming down on you, but even when at night, there's a lot of heat trapped by concrete that keeps radiating at night, and you just keep feeling very hot. And so there's a lot of urban areas where AC air conditioning is very expensive, and it's also has a lot of emissions. And so these tools can help curb that. And so the idea is that cool roofs are designed to reflect sunlight and absorb less heat. And for example, Iniciativa Climática de México is working with city officials to evaluate Mexico City's building emissions. And they have the potential to generate 4 megawatts of renewable energy just from rooftop solar. And they're using data from different sources. And so there's a lot of exciting stuff going with our Environmental Insights Explorer at the city level, but also at the user level. You can go and with the same satellite imagery and a similar artificial intelligence, we detect the rooftops potential of your own house to see like what is the amount of solar energy that you could be getting if you invest in solar panels. And so again, this is a same type of technology, image recognition, and in artificial intelligence that can help us curb emissions. Also, we have the Google Earth time lapse. If you're familiar with it, and this is like again, I'd encourage you to check it out. We have a large scale geospatial analysis, which is used a lot for research and other organizations that are trying to understand and fight climate change. It includes 25 petabytes of freely available geospatial data that provide valuable information for scientists and environmental organizations. And the idea is that it can be helpful to understand the causes of Earth's change. We work with experts at the Carnegie Mellon University at Create Lab to get the technology behind the time lapse. And unfortunately, and like this is a very cool tool, but you can kind of see live, even in this movie I'm putting here in this GIF, you can watch the cities grow, but you can also watch how forests disappear and measure the rate of disappearance, how glaciers recede, and how the lakes dry up. And so this is very, very useful and also kind of unfortunate. All right, so this is a few of the tools and projects that we have for combating climate change. But as you know very well, alongside with combating climate change, we need to start creating and tools to adapt to climate change because it's already here. And so artificial intelligence can also help communities adapt to the present climate crisis. And for these, we're creating the tools to warn for fires, droughts, huge like extreme climate events. And one area of interest that I'm very excited about and want to talk to you about is floods, because floods are like an important are very important for lots of regions in the world. And then one of the most deadly and natural disasters on the planet. They affect more than 250 million people globally every year and cause around 10 billion in economic damages. So we want to avoid floods as much as possible, but we also want to be able to warn people when there's floods, when there's a flood danger. So we began our initiative to forecast floods back in 2018 so that we could warn people before the flooding occurs. And we first piloted in India and then expanded to Bangladesh. And now we have forecast on the 80 countries. And this has been an exciting expansion. We're covering riverine floods in areas with 460 million people across Africa, Asia, Latin America, and 31 countries in Europe. You can kind of see there's a lot of coverage in South America and Central America. Mexico, unfortunately, is not currently on this list. But all the flood forecasts are available for free and up to 7 days in advance on the platform, so that governments and aid organizations and people in affected areas can take action to save lives and limit the damage. And so, as I said, this is all based on artificial intelligence, and this is not only image recognition that we're using for this. So let me explain the model a little bit, and then I think I'll leave the rest of the time for questions. So this expansion was based on recent advances in artificial intelligence-based global models. So as you probably know, we need very large data sets and a lot of weather data to model the climate for the whole globe. And this, because if you've heard, the climate has this kind of chaotic characteristic where climate here in California might affect climate in India. And so we need to model a big, we need a big model to model the whole climate of the Earth. And then in particular for these floods, we use two artificial intelligence models. We feed it publicly available data sources such as weather forecasts and satellite imagery. And the data feeds two models. One is a hydrological model, which forecasts the amount of water flowing in a river. And so for these, we need the weather because depending on how much rain or whether there's a drought or not, or how are the clouds moving along the atmosphere, we have information about like how much it's gonna affect the water flowing in any specific river. And so this model fits into the inundation model. And for the inundation model, you can kind of see in this GIF, there's a few sensors in some rivers that we use as training data, where we want to predict what is the amount of flood that will cause a certain like amount of water flowing. And so for these, the inundation model predicts what areas are going to be affected and how deep the water will be. And so with these two models, we have devised a flood warning system that can tell you 7 days in advance whether you're going to have a flood or not. And this helps people either evacuate or bring resources in order to kind of curb the damage. So let me leave it at that in case there's questions. But again, thank you for listening and for the invitation.
Thank you very much, Aaron. I think that the topic you presented is very interesting, and there's a huge connection between the use of technology and how we can use it to our future, and how we can use it to prevent some casualties or anything that climate change can climate change in the future. We have some questions here. Just give me a second to read it.
Yeah.
So one of them is, what kind of hardware does Google Research have to process all this kind of aerial information or geographic information?
That's a great question. So Google actually doesn't own. So for example, I'll speak particularly to the Contrails project, which I know the most about. There, we don't own the satellites. These satellites, for example, we use a GOES 16 satellite, which is a geostationary satellite that overlooks America, and we're also involved in with another geostationary is well, I should say this is an American satellite, and I believe it's owned by NASA. And then there's another satellite by the Japanese space agency, which is called Himawari, and then another one by the European Space Agency, which is called I'm blanking on the name right now. But with these three satellites, we're hoping to map the entire globe and do this contrail avoidance at a global scale. But we don't really own the satellites. We either enter into like a contract agreement with third parties that own satellites, or Go 16. I believe the information is publicly available. And for the flood AI systems, for example, for their training, I think a lot of the data as well is publicly available.
All right. We have another question here from Columba Martinez Hernandez. Is asking, with AI, when you predict some flood in in a country, what is the percentage of effectivity that these models have in real sense?
So I think effectivity, if it means like how much resources or people we can save, I think that depends a lot on the like case to case. I don't. So we recently rolled it out to 80 countries, and this is a kind of a new product. I know that in India and Bangladesh, it has been working very well because you can at least evacuate people by warning them 7 days in advance. Of course, material goods are not as easy to kind of relocate. Some are and some are not. Houses, of course, are not. But I think it's a little bit early to tell what the like effectivity is. But I believe that with good coordination, these warning systems are kind of going to be put into place, and now we need to learn how to react, which is not a small task, but how to react and how to evacuate as much people as we can as fast as possible, etc.
All right. We have a few more questions. Regarding the flights, the part that you talk about the flights and how the engine can, like, moving a few feet away from Earth can literally change emissions. What is the main greenhouse gas that is emitted on the atmosphere that can produce that kind of huge impact on climate, depending on the altitude?
Yeah, that's a good question. So if you think about like greenhouse gases in general, the idea is that they're trapping heat from escaping Earth, right? So the outgoing long wave radiation that would have escaped Earth um, kind of bounces back because of the CO2 or the methane or the nitrous oxide. And so there's a fourth. Well, there's many greenhouse gases, but this condensation trail is made of ice crystals, which
It's
are
ice, right? It's
yeah.
okay.
So the airplane when it flies by, it releases soot, like these tiny particles, and when there's a like relative humidity is high, they nucleate around these particles and form ice crystals. And these ice crystals are the ones that are the kind of culprit of that kind of get the radiation to bounce back. And they're very what is called optical dense. These clouds in particular, and so that's why they trap so much heat.
All right, so actually it's not a gas, it's a crystal, it's solid water that makes the light to be trapped inside the atmosphere, right?
Yeah, that's right. That's exactly right.
Okay, that's very interesting. Okay, I have here another comment. Muchas gracias, Aaron. ¿Dónde puedo leer más sobre tu trabajo y línea de investigación en este laboratorio de Google?
Es buena pregunta. I can contesto en
Sí, puedes contestar en español.
Tenemos una página, de hecho, el artículo del experimento de American Airlines salió en el New York Times hace un par de semanas. Lo pueden buscar ahí, pero también si buscan Contrails Google, tenemos una página de internet sobre este proyecto en específico. Puedo poner el link aquí en el chat.
Sí, pásamelo y yo lo paso al grupo.
Y también está el proyecto o sea, Google Research. Dentro de Google Research está mi equipo que es Climate and Energy, del cual pueden buscar.
Perfecto.
Buenísimo.
Okay, so Aaron, thank you very much. Muchísimas gracias. Creo que los temas que abordaste son súper interesantes. Hubo mucha reacción del público. Te agradecemos muchísimo por haber estado aquí en el Foro de Bosques y Tecnología. Y thank you very much to Google Research for all your team, all the work that you have been doing. And see you maybe in next year's Foro Bosques en Tecnología.
Of course, thank you for the invitation, and it's very exciting to see this happening in Mexico, so please keep me involved.
All right, thank you, Aaron. Thank you very much. See you soon.
Bye, thank you.